By the way, whoever wants to give me their Bitcoin wallet and private keys, I will not see it like the AI. I'll keep it safe. Okay, so I'm Isaac, CTO of Simply Staking. I've been involved since co-founder since the beginning. We started off in a very different setup to what we run today. We started running a few nodes and a few servers, and now we have 3 data centers, one in Malta, one in Netherlands, and one in Canada. And we run like 100 different blockchains. Okay, is this better? Yeah, okay. We run like 100 blockchains. We do blockchain development. We give RPC nodes out to clients. We run oracles. We have a data team which is mining our data for tax reasons. So yeah, we do a bit of everything. Okay, so yeah, this was supposed to be the slide for the background. Okay, so today I want to talk about interoperability and what this means. And we have Jane here to give us an example, an analogy. So basically, meet Jane. Jane lives in the new digital age. So Jane invested in a few ICOs back in 2017. And she would like to hold these funds for a while. So Jane has been working very hard, and she's tired, and she would like to take some time off to travel. But she does not want to liquidate her savings. She keeps investing in crypto, and obviously she went to the bank, and as any bank would say, you want a loan, but you don't want to work. How are you going to pay back the loan? So nobody's going to give you a loan. So, oh no, like, what's she going to do? So we have DeFi that can help. So she could use her crypto, like she could have her Ethereum, her Chainlink, her whatever she has, and she can get a loan without spending that crypto. She can get a loan on chain without any months or years waiting for the bank to give you the sanction letter, and like we all know how it goes, like how long it takes to even open a bank account these days. On chain, you could just set up an account, and it's permissionless. Everybody can do it, and we can get a loan immediately. So her journey through the DeFi world would be quite simple. So she's got, for example, I'm using Link as an example here, the Chainlink native token. So she would like to grab some of her Link and use it as collateral. So she can go to Aave on Ethereum or any other L2 which is supported on. She could use her Link to borrow USDC. So basically, she goes to the Aave protocol, gets the USDC, and then now she needs to spend this USDC. So how is she going to spend this other token that she got? So she could go to Gnosis chain. So you need a bridge. We'll explain how that works later. She can use Safe on the Gnosis chain to get a credit card, a physical card that she can use to pay her travels, her food, whatever she wants. So how does this work? So this is where the old blockchain infrastructure comes into play. So any transaction that we want to do on the blockchain, you need an RPC. So an RPC is a blockchain node. So these are massive servers which have a history of all the database of the blockchain. And in order for a normal person to interact with the blockchain, you need one of these RPC nodes. Now, if you're using MetaMask to do a transaction or any other wallet, most of the time, these already have like pre-built RPC nodes, but these are running in the background. So somebody is providing you this node for free. But when you're a business, you need your own RPC nodes to make sure that your transactions are not messed around with, and you need quick access. Like if you have an arbitrage bot and you need to submit money transactions, you need to know that your transactions are going to be submitted when you want them to be submitted. So you need access to your own node. However, running this node is quite cumbersome. They're massive machines, like 1 to 8 gigabytes of RAM, like 5 to 20 terabytes of hard disk, lots of bandwidth. You need to have like full uptime on them. So it's not something that you're going to run in your house. One service is RPC providers, such as ourselves and some others. Then you need an Oracle network. So in order for Aave to know what your link is worth, it needs to have a price feed for this link. Obviously, if a protocol is getting a price feed, you need to ensure that the price feed that you're getting, if it's telling you link is worth $30, it's actually worth $30, because otherwise you can inject data and fool it. So an Oracle network would be made up of multiple data providers, multiple node operators who will submit different prices from different providers. Once this data is on-chain, then it's aggregated, the median is taken over the price, and then this price is submitted on-chain for these protocols to use and trust, obviously. So that's why it's important to use a trusted Oracle, not like any smart contracts which has price feeds, because if anything happens to that price feed, then your protocol is vulnerable to an attack. So then once the Oracle network provides you the data to on-chain or on your smart contract, then you can go ahead and issue the loan, because you know that their link is worth X amount, so you could give them a loan for X amount. So then Jane got her USDC, but now she needs to move it to another blockchain in order to use the safe. So in order to do this, you need to have your USDC on, for example, Ethereum, and now you need to bridge it to Gnosis chain. So we need a bridge here. So what is a bridge? A bridge is a bridge, basically. So it is two networks and some technology, call it like an API between these two networks, which will say, okay, Isaac or Jane has $100 on Ethereum in USDC, and now he wants to move them, or she wants to move them to Gnosis chain. So basically what happens is an IOU, so your funds are locked on one side of the bridge and then minted on the other side of the bridge. So there's multiple ways how bridges do it. Either they get banked on one side and minted on the other side, or it's an IOU. So in this case, we're using CCIP from Chainlink. So Chainlink would see that you actually have money in this wallet on Ethereum, and now you want to move your USDC to Gnosis. So the bridge will make sure that the transaction is real, and your tokens are moved from one protocol to the other. So now you've moved your tokens, so your tokens are now on Gnosis chain. Now there's another application on this chain called Safe, which issues you credit cards, and you can use the funds in your wallet on that chain to spend money in the real world. So, yay! So that's a complicated way of how DeFi will allows us to use our money from the DeFi world, from Web3 into the real world. So some of the infrastructure that we've mentioned were like validators. So every transaction that happens on a network needs to be verified by these machines, which are called validators. So validators, besides securing the blockchain, also make sure that transactions are valid, that you cannot double spend, that you cannot say, I have $1,000 in my account where I actually don't have this money in my account. And these validators basically are like notaries in the real world, where they make sure that nobody is cheating. Oracles, as I mentioned before, oracles are these machines which verify truth and bring either off-chain data to on-chain or on-chain data to off-chain. So basically, as I was saying before, like we need to verify that the price of link is X and it is real, because any protocol that needs to get this data. So one thing about blockchains, they cannot search the internet. So a blockchain node cannot go do an API call to a Web2 protocol and get the price feed. The price feed needs to exist on the chain. So for a smart contract to know the price of anything outside of that blockchain, it needs to basically somebody needs to submit that price to it. And this is how we use oracles. CCIP, this is the bridge. What I mentioned, that moving tokens from USDC from Ethereum to Gnosis is useful. So basically, we need to keep in mind that when we're using a bridge, it's like moving US dollar to euro. So you have a bank, which is your bridge, they're doing the FX for you. This is the same thing, but this is there in chain. There's no middleman. There's a network, and this is like pretty instant. There's some, depending on the protocol, there could be some unblending period, but they're pretty fast. So RPCs, one of the new services which we have launched is an API service for RPC nodes. So you can log into a website and you say, I need an RPC node for Ethereum, for Chainlink, for whatever protocol you want. If we're running it, we run like 50 or 60 networks on Spectrum. So you can just log in, sign up. We have a free account where you could get a few transactions, and then if you need a lot of transactions, you can get a paid service. Basically, obviously, a service like this saves you from running your own infrastructure, so that's pretty useful. Sorry. Remote procedure call. So it's like doing a call. It's like an API call or like a request to anything on the internet. It's like when you launch your website, you're basically getting data from that website. It's the same thing, but for a Web3 protocol. So you querying a node, and this node is giving you the data. So you can ask it the balance of an address. You can ask it the balance of an address at a current date and time. You can ask it like whatever is on that network. You can query through an RPC call. Welcome. And obviously these use need to be highly reliable because a lot of infrastructure on the internet or Web3 depends on this infrastructure. So Web3 services are as reliable as we've come to, or we're trying to make them as reliable as we've come to depend on the internet. Like back in the day when the internet was, up and coming, you'd go to visit a website and the website would be offline because people were running it in their garage. Nowadays, you have web server farms all over the world running websites like Amazon and stuff like that. So the same thing is happening with blockchain tech. So this is like a snapshot of what it takes to run these nodes. So like an Ethereum node would take like 48 gigabytes of RAM and 4 terabytes of hard disk and 40 megabytes per second of bandwidth. That is pretty megabits. Sorry, that's pretty intense. Like a Solana node uses 2 gigabits of bandwidth. That is, wow, that is a lot of bandwidth. Like most cloud servers would give you 1 gigabit of bandwidth. So like that's intense. And the RAM, like a Solana node, uses 1 terabyte of RAM. That is like a server to run or a Solana node would cost you like 30K just to run one, and you need to have multiple of them for redundancy. Then like there's other nodes like an Arbitrum node, which is not as hungry as like Solana. Solana is the hungriest blockchain out there. Sorry? Yes. So blockchain tech is still up and coming. So like the technology, the protocols themselves are not optimized. Like we've on the internet, like on Web 2, we've had 20 years to optimize. This is a new technology, so it's still being optimized. So at the moment, in order to optimize, we just buy bigger hardware. But they are working on optimizing these protocols, and at some point they will be. So, but unfortunately, right now it's just buy bigger machines. Okay, so what powers Web 2 and Web 3? We've heard a lot of talk about Web 2, and we know and Web 3. So it's pretty much the same stuff. Like it's the same data centers and the same cables throughout the world. So over here we could see pointer. We could see there are fiber optic cables crossing all over the world. And this infrastructure is used for both Web 2, which is the internet, and the internet is the driver behind Web 3. We've had a big evolution in communication. So up until a few years ago, all the communication was done through fiber optic cables throughout the world. But now we had a few satellites delivering services. But now we have all these satellites. This is the Starlink network. All these. There's like thousands of satellites, and before wireless internet wasn't really reliable, especially over such long distances. But nowadays we could say that like we don't need to. Before, communication was dependent on the fiber optic cables in the oceans and on mainland. Nowadays, there's so many satellites up there that sometimes it is even more efficient to use the Starlink network than to use the fiber optic cables, because these satellites can now talk to each other. So from Malta to America, instead of traveling like 15,000 kilometers, the satellites could talk to each other and like shorten the time between the locations. So it's pretty impressive how technology has improved, and all these evolution and technology helps us deliver better services. So when it comes to running any infrastructure, there's two options. You can use the cloud infrastructure. Don't use the cloud. Or the physical infrastructure. So for some services, it makes sense to use the cloud if you're running a Web2 application. The cloud is highly optimized for this. You can run your website in AWS, Azure, and they're very customized for running traditional websites. However, when it comes to Web3, as we were saying, these protocols are not fully optimized yet, so they require a lot of resources. And basically, the difference is that if you're running on the cloud, you don't know where you're running. You're running on some server somewhere, and you don't know who else is sharing this hardware with you. So if you really don't end up running on the cloud if we're running on the cloud, because we're going to trash the server we're running on. So if you're running in the cloud and there's somebody who's trashing the server, you're not going to get good performance. Some cloud providers sometimes just discontinue, like blockchainers, like Hetzner, for example, was a popular service provider. They're subsidized by the German government, so they're quite cheap. However, like there were like a lot of people running Solana nodes over there because it was pretty cheap to run a Solana node on Hetzner. And at one point, these guys said, these guys are really using a lot of bandwidth and using a lot of electricity. And they blocked like Solana nodes, like got kicked out of Hetzner from one day to the next. Like the Solana network took a dip. And there were other networks that got banned, and like this is a big centralization problem, because if you're running all your nodes in one data center and the data center goes down, your blockchain goes down and you cannot offer a service. And if you're using the big four clouds like Amazon, Azure, Google, the bandwidth costs are so extreme, and the costs of running there, we would lose money if we had to run that. So what do? We run our own data centers. We run our own hardware. We buy the physical hardware ourselves, configure it ourselves, so we can optimize, the whole shebang from the wire to the software that we run. We can predict our growth, and we can buy in bulk and get better deals, and we can offer decentralization. So we offer networks, different data center, different locations where they can run from. So if there's a big cloud provider, once, like a few years ago, Microsoft had a total outage on their whole Azure platform. It was literally down to a certificate expiring, and their whole platform went down. So any protocol that was running there had problems for like a number of hours. The more different providers you have, the less chance that something like that happens. So what we also provide is physical infrastructure as a service, so we could operate nodes securely and highly available. We can take the heavy lifting, so if you need to run these nodes, we can run them on your behalf. We have a lot of experience running these networks, and we can help any project scale up. And we offer a tailored service. So if you need a node that is a bit different than any other node that any other provider will not provide it, we offer like tailored services. And we just launched a free version of Spectrum, our RPC service. So if you have a few requests, go ahead. Go on our website, set up a free account, and you have free access to our nodes. That's it. Cheers.
We are a crypto-native community that aims to learn and share knowledge together. Join us at Soho, The Strand, every Wednesday to dive into our questions section live.